Hi everyone, welcome to my YouTube channel lecture series on microcontroller and processor. Now I will be going to explain how to write an assembly language program for division of two 8-bit numbers using 8085 microprocessor. So when you want to perform a division of two 8-bit numbers, we have to have two 8-bit of datas, and these datas need to be loaded into addresses. Then we can perform a repeated subtraction process. Basically, the division is a repeated subtraction, and multiplication is a repeated addition process that we have to remember. Okay. Now I'll move on to the instruction part. I'm going to use the instruction LXIH, 4500. So when you use LX is nothing but you're going to load. When you have X, the X stands for you're going to load the 16 bit of data. So here the data 16 bit of data which I'm going to use as address, that is 4500, and I stands for you're going to immediately move this data LXI. H is nothing but you are going to use HL pad, but you cannot see the L here, but in the instruction set, the mnemonics it is given by the manufacturer, it is H. The H stands for HL pad. So only the pair of registers we can able to store the 16 bit of data. So I'm going to use a HL pair. I'm going to load my address 4500. So after loading this first data into 4500, I'm going to move this content, the content which is available in 4500. That is a memory address I'm using for loading my first input data. So I'm going to use a memory address is 4500. Whatever the data available in this memory address, I'm going to move to the B register. So I already mentioned in the addition subtraction program, I can use any temporary register to store my first data. So here I've used a B register where I'll be going to load my first input data. So second input data I have to load in the second next memory address. So before that, what I'm going to do is I can initialize the carry register. If any carry is generated, you can store the carry value. So what I have done is I just used instruction move immediate. The immediate in the sense you're going to use 8 bit of data immediately to the C register. So when you give a 00 8 bit of data to C register, which means you're going to clear the carry register. Okay. So after clearing the carry register, in case if you have any carry, you can store the value in the C register. Okay, that is the purpose. I initialize the carry register into 00. Next, I need to load my second data. The second data, I'm going to use an instruction called increment H. What we can do is, you can increment your address by 1. So what is the address? So address is nothing but the HL pair has address of 4500. If you use the instruction INXH, you are going to increment this address 4500 into 4501 to load my second 8 bit of data. So first data is nothing but the divisor, and the second data is nothing but your dividend. Okay. So after loading these two data, what we can do, we can just move this data. The second 8 bit of data, you can move to the accumulator. So how we have performed for the first case, right? The same way you are going to move this second data, that is a dividend, you are going to move to the accumulator. Then I'm going to use a compare operation. In the compare operation, you can either compare the B register with the accumulator data. So there are three cases you have. If the A is greater than B, the carry is equal to 0. If A is less than B, you can get a carry, and A is equal to B, the 0 flag will be set. So you have three conditions for compare operation. If the accumulated data is greater than the B register data, then there is no carry generated, which means the carry flag is reset. If A is less than B, the carry will be generated, so the carry flag will be set. When A is equal to B, the 0 flag will be set. So how to understand the compare operation of 8085 processor? So based on this, we can do a repeated subtraction now. Okay. So we are going to compare the A and B. A with the B register. So I'll just explain with this truth. Explain with the table so that you can easily understand. So the first data is nothing but the divisor which have been loaded in 4500. So the data which I have taken is 4. Next, I'm going to use move B comma M. So B comma M is the data which is available in 4500. I'm moving into B register. So what is the data available in 4500? It is a value of 4. The 4 I'm moving into B register. Next case, I'm using the C register. I'm going to clear the C register to store my carry value. So I have cleared with the value of 0, 0. So the C register data is 0. Next, I'm going to increment your HL pair by 1, which means 450001. In that, I'm going to load my second data. So the second data which is available in this memory 4501 is moved to accumulator. So what is the data available in 4501? It's nothing but 8. 8 is a second input data, that is a dividend. This I am going to move to the accumulator. So the accumulator has a value of 8. Okay, so accumulator has a value of 8 now. Now after getting this two input data, I can do a compare operation. So what you are going to compare? You are going to compare A and the B register. Now we can check the A is greater than B. Okay, so A is greater than B, there is no carry generated. Okay, so what is A value? The A is 8 and B is 4. So 8 is greater than 4. Okay, if A is 8 is greater than 4, there is no carry generated, which means the carry flag will be reset. So you can do a next instruction, jump carry, then it will go to skip and store the result. If there is no carry, you can do a repeated subtraction process. Okay, so here the A is greater than B, which means 8 is greater than 4. We can go to subtraction. Okay, what do you mean by subtraction? The subtraction, subtract B in the sense it is going to subtract A minus B. Okay, so what is the data A? The accumulated data is 8 and the B register has a data of 4, right? So 8 minus 4, you will be getting answer as 4. Okay, this 4 will be automatically stored into the accumulator. Okay, so now the accumulator has a value of 4. Okay, so what is the next step? You have to increment your carry by 1. Okay, so I'm going to have a carry register. I'm going to increment this by 1. Jump to loop. Okay, so again what you are going to do? You are going to perform the repeated subtraction process. Again you are going to compare A and B. Okay, so jump to the loop. So this will come here and it will compare the accumulated data with the B register. So what is the accumulated data now? The accumulator has a value of 4 and the B register has a value of 4, right? So 4 is equal to 4, then the 0 flag will be set. Okay, if there is a jump with carry, then it will store the result. If there is no carry is generated, again it will do the subtraction process. So the next step what it will do, it will subtract A minus B. The A is also 4 and B is also 4, right? So the next step, it will take 4 minus 4. Okay, so the answer is equal to 0. Okay, where this 0 will be loaded, the 0 will be automatically loaded into the accumulator only. After it performing the subtraction process, the result will be automatically loaded into the accumulator only, right? So the accumulator has a value of 0 now. Then you are going to increment your C register by 1. So you are going to increment this 1 into 2 here. Okay, so you are going to increment your carry by 1. Okay, then jump to loop and you again do a comparison. Okay, so if you compare A minus B, okay, A and B, what will happen? The A has a value of 0, but the B has a value of 4, right? So A is less than B, right? So if this condition is true, A is less than B, then there is a carry generated. Okay, the carry flag will be set. So you can go to the next instruction, jump if carry, because the carry is set, you can go to skip here, okay, and you can store your result. So what is the result you will get? In the 4502 you will be getting a remainder. So what is the remainder? The remainder is 0. Okay, remainder is 0. Then you can whatever the data available in the C register, that can be moved to the accumulator and you can see the quotient value, right? So here the quotient the C register is incremented to 2, so the 2 will be loaded into the accumulator now. They will be moving to the accumulator. After that you can store this accumulated data into 4503. So in 4503 you can see the quotient. Okay, so 4 by 8 is 8 by 4 is 2, right? So 2 is the quotient and the remainder will be 0. Okay, this is a remainder and this is a quotient. Okay, so this division process is a repeated subtraction process. So every time what you need to do is you need to compare the accumulated data with the B register. If there is the accumulated data is greater than the B register data, the carry flag will be reset. If it is less than accumulated data is less than the B register, the carry will be set. And accumulated data is equal to B register data, then the 0 flag will be set. So based on these conditions only, you have to execute your division operation. So every time we need to do a repeated subtraction process so that you can carry out your division process of 2 8-bit numbers in 8085 microprocessor. Thank you for watching.